Okay. So I'm just proceeding with the free body diagrams again. Okay. So suppose I'm assuming that there is a surface. This is a surface on which an object is placed, which is having a mass of m. I am assuming this is a point mass. So that's why the weight of that object is working in downward direction. It is of m into g. And to balance it, obviously the normal reaction force is acting in upward direction, vertically upward direction. So in that case, we can see that all the forces which are acting on this object, we are able to represent this in one diagram. So this kind of diagrams are known as a free body diagrams. Okay. If we have an inclined plane like that, suppose we have an inclined plane. On that plane, one of the object is placed. This is having a mass of m. So we can say the weight of that object is working in downward direction like this, and the normal reaction force will work like this. Okay. As you can see, there is an inclination angle that is of theta. So we can say that if we just draw a normal line, okay, which is perpendicular with respect to the object, so I can say that this angle is also theta. We can say if the inclination angle is theta, so the mass is m and the weight of the object is working in the downward direction. It is of m into g. So the normal reaction force will work in the upward direction. It is represented as n. But as you can see, the object is placed on an inclined plane. So there is an inclination of theta. So if I draw a perpendicular line with respect to the position of object, and there the angle I have found as theta. So this is actually the base with respect to which the angle theta I have represented. So along the base, which component works? Cos theta or sin theta? Everyone, along the base, remember one thing, along the base always the horizontal component will be represented. So I can say along the base mg cos theta will work, and in the perpendicular direction, suppose the object is tend to move in this direction, so obviously we can say mg sin theta will be directed in that direction. This is the vertical component. I'm just zooming into the picture and I'm making you understand again. In this case, the object was placed on an inclined plane which was having the plane of inclination as theta with respect to the horizontal. So the weight which is acting in a perpendicular direction, and it is not depending on the inclination or whatever. So the m into g, the weight of the object, is just working vertically downward direction, and the normal reaction force is acting in vertically upward direction. But if we consider that the object is placed on an inclined plane, and with respect to its position, if I draw a perpendicular dotted line, so with respect to that line, the weight is working at an angle of theta. So as we can see that the weight is acting like a hypotenuse of a right angle triangle. So obviously with respect to its base, the cos component will work. So that's why we can say in the downward direction of that vertically dotted line, mg cos theta component is working, because this is the base with respect to which the angle theta is formed. Okay. Or I can say that the weight of the object is working at an angle of theta with respect to the vertical line. So what is the vertical component of weight? That is mg sine theta, which is working in this direction as I have drawn. Whether this thing is clear?
Yes,
Everyone,
sir.
thank you.
Yes, sir.
Actually, this thing is very much important whenever we'll understand the free body diagrams. That's why I have explained this. Now, one more thing. Suppose if that happens, that there is a pulley, okay, there is a pulley and the two objects are hanging with respect to this pulley. This is an object M1, there is an object M2. So what I can say that how the free body diagrams can be made with respect to this one for this M1 and M2. Actually, so sorry, I have just made the diagram that it already is not being straight, but you can move your phone to see the diagram in a straight way. Even I can zoom into that picture as well. So just I want to draw the free body diagram for these two masses. So what we'll do here, in this case you can consider, if you assume this as point mass, so for that M1, the suppose this is a point mass M1, for that the weight is acting in the downward direction, this is of M1 into G, and the tension force is working in the upward direction, this is of T. Okay, for M1 we have drawn it. Now for M2, suppose this is of M2, so I can say that the weight of that object is working in the downward direction, that is of M2 into G, and the tension force is working in upward direction, this is of T. Sorry, by mistake I have written T1, this should be of T. The same tension force is working here. So actually in both of the above diagrams, I have not drawn the free body diagrams actually, I have drawn directly. But if you want, you can draw like this. But I think you don't need that because you know this phenomena very well. So that's why in this case, I can draw the whole thing in the diagram that is shown here. Okay, because in the previous diagram we just have assumed that this is actually a point mass, but we have not drawn like this is a point and in the downward direction some force is acting. We assume just this is a point mass for the first one, and we have drawn all the forces which is acting on it. For every cases we have assumed, but for this case, to make you understand more clearly, I have drawn the point mass. Okay, so if I not draw the point masses for the third case, what should be the diagram with respect to the given one? So this is M1 into G, and this is the tension force T. For this M2, this should be the M2 into G, and this is the tension force T. If you just combine these two diagrams, then this is the complete one. Whether it is clear, everyone?
Yes, sir.
Okay, that's very good. Now, one by one, we'll just understand all the things with respect to the free body diagrams. Because in the Newton's first law of motion, it was said that whenever an unbalanced force is not applied on an object, the object will not change its state. That means if an object is in the state of rest, it will continue to be in the state of rest. And if the object is in the state of motion, it will continue to be in motion. Right? So we can say that whenever an object is in the equilibrium position, okay, suppose an object is in an equilibrium position, the sum of all the forces, or you can say the sum of all vector, which is all the vector forces or all the force vectors which are acting on an object, they are zero, right? According to the Newton's first law of motion, I can consider that there is an object which is having a mass of m. In this direction, you are applying a force of F1 vector. In the opposite direction, you are applying a force of F2 vector. In the downward direction, you are applying a force of F3 vector. In the upward direction, you are applying a force of F4 vector. So the summation of all the forces, all the force vectors, they are zero. That means summation of Fn vector, it is equals to zero. That means F1 vector plus of F2 vector plus of F3 vector plus of F4 vector, it is equals to zero. This is actually the Newton's first law. Whatever the force we are applying on it, if their sum is zero, there will be no change in the state of the object. But if the sum of all the force vectors are not zero, then there will be a change in the state of the object. I am repeating that thing. If the sum of all the force vectors are zero, then there will be no change in the state of the object. The object, if it was in rest position, it will be in rest. If it was in uniform motion, it will continue in uniform motion. If the summation of all the force vectors are zero, then it will happen. But if their sum is not zero, then obviously the object will change its state. Okay, whether it is clear?
Yes, sir.
Okay, that's very good. Now we are just going to move for the free body diagrams again. This is actually the way by which we can write down the Newton's first law in that vector form. I have just given you only one example, but this is universal actually. This condition, whatever I have described, this is valid for all the different kind of objects for all the situations. Now, if it is given that you have to find out the tension force, okay, for that I'm just giving you one smaller one, that there is a fixed plane with respect to which the object is there, okay, even the object is attached with another fixed plane, okay. In this case, with respect to the vertical, I am saying this angle is of 30 degree. This is having a mass of 5 kg. So the question is, find the tension force in both the strings. Just write down the question, draw the diagram, then I will explain.
Certain.
Okay. Now in this diagram, everyone, just have a focus. So what I can say, that if that angle is 30 degree, so you know about the alternate angle, na? So we can say that if I draw another parallel line with respect to this point, this is the parallel line that we have drawn here. Okay. So with respect to this parallel line, I can say that this angle will also be 30 degree. So if it is 30 degree, then why? Then I can say that the tension force is acting in the upward direction. I have already said that if the object is attached with a string, then obviously the tension force will work in the upward direction. Suppose this is of P. Then which is the base with respect to which the angle is working? I'm just making the line so much colorful thus you can understand it well. Which is the base with respect to which the angle is represented? The white color line is the base or the yellow color line is the base?
Sir,
Everyone,
the
just see
white
that
color.
white color line,
White
obviously
color.
it is the base. Yeah, obviously. The white color line is also the base, even the yellow color line as well. Because you have to consider that what is the tension force is acting with respect to the object. So that's why we are considering this one, and I can say that along the base T cos 30 will work, and in the vertical direction T sine 30 will work, right? Even the object is having a mass of 5 kg, so in the downward direction the weight of the object will work. Suppose I am assuming it is having a mass of m, so the weight of the object should be m into g. Later we'll substitute the values, okay? and there is another string which is attached with the 5 kg. So along the string, the tension force will be different. It will be of T1, right? There are two strings, so there will be two tension forces. The tension forces will be different. The string which is acting at an angle of 30°, the tension force which is acting along it, this is of T. But the string which is horizontal and it is attached with the 5 kg, this is having the tension force as T1. Whether up to that much, it is clear or not?
Yes, sir.
Okay, only one Gagan, and I think Preeti and rest of the people. Say fast.
Yes, sir.
Okay, now what I have to do in this position, I have to make equal all the forces. That means the upward forces will be equals to the downward forces. The forces which is acting on the left hand side will be equals to all the forces in the right hand side, because the object is in equilibrium position. So I can make equal that this T cos 30 will be equals to this mg. That means the upward forces will be equals to the downward forces. T cos 30 is equals to m into g. First conclusion. Second conclusion, that is of T1 is equals to T sine 30. All the left hand side forces equals to all the right hand side forces. T1 is the tension force which is acting in the right direction. T sine 30 is a force which is acting in the left direction. So at the equilibrium position, all the forces are having the equal value. Like this, all the left hand side forces will be equals to right hand side forces. All the upward forces will be equals to all the downward forces. So cos 30 is having the value of how much? Cos 30. Everyone, you have to practice your trigonometry. How many people are not having the math? Everyone, how many people are not having the math? Okay, I think all of you have the math. Okay, that's actually I'm not able to check the chat messages, no? Okay. Now cos 30 is having the value of root 3 by 2. If the gravitational acceleration is not provided, assume it is of 10 meter per second square. Mass of the object is 5 kg, so it will be 5 into 10. So now what should be the value of t? It will be of 5 into 10 into 2 divided by of root 3. So 5 tens are 60 or 50. This is a 100 divided by of root 3, that much Newton. So if you have obtained the value of t, you can substitute the value here. So that means t sine 30 will be equals to 100 divided by root 3 multiplied by sine 30 is having the value of half. So this is 2 ones are 2, 250 is 100. So it is equals to 50 by root 3 Newton. Simple, easy. Say up to that much whether it is clear or not. So easy na?
Yes, sir.
Okay, that's good. So step by step, I will increase my level. Okay, this is the basic level. This is nothing. Just write it down, then we'll go for the next. All the base level will complete. In class 11, actually, only two chapters are my favorite. First, no, 2 to 3 chapters, I can say, because they have lot of things to learn. First one is the vector, second one is Newton's laws of motion, third one is thermodynamics. It's a great chapter. Everything is covered in that. All the chapters are like the child of them. And one more chapter, that is SHM. SHM is also a great chapter. Now, whether it is completed, everyone, do you have any of the doubt?
No, sir.
Okay. Now, the next diagram is, suppose there is a fixed plane with respect to which an object is attached with both of the string. Okay. This object is having a mass of 2 kg. Okay. In this case, I am giving you the angle of inclination. For both of the cases, the angle of inclination is different. Suppose this is of 30°, this will be of 60°. So obviously the tension force which is acting along this one, if it is of T, then obviously it will be of T1. Okay. Now you have to find the tension force. Find the tension. Finding of tension is also a tension. No? Just find out the tension force. Do you want to make the free body diagram, or you can make the FBD, the free body diagram, in the figure? If you are comfortable to draw in this figure, then it's well and good. If you have to make it in a different way, like assuming a point mass, then you can draw it separately as well. I think you need to draw it separately. Whether the diagram is drawn, everyone, whether you can move for the solution.
Yes, sir.
Very good. Now we can say that it is a point mass, there is a point mass, and these two are the tension forces which are acting on it, right? Suppose I have assumed this is of T and this is my T1. Okay, this is the horizontal line with respect to which it is having an angle of 30°. So I can say in the horizontal direction, which component will work? Like the component which is acting along the base, that will be T cos 30. The component which is acting along the perpendicular, it is actually T sin 30. For this T1, the component which is acting along the base, this is of T. Oh, just wait for a minute. By mistake, I was writing that S word. So if this is T1, so there is an inclination angle of 60°. So with respect to the base, which component will work? Obviously T1 cos 60. And with respect to the perpendicular, which component will work? Obviously T1 sin 60. I am zooming the figure. Now just see the diagram. For this tension force T, the angle of inclination is 30°. So along the base T cos 30, along the perpendicular T sin 30. For this T1, along the base T1 cos 30, along the perpendicular T1 sin, along the base T1 cos 60, along the perpendicular T1 sin 60. Why did this free body diagram is clear, everyone?
Yes, sir.
Okay. Now the weight of the object we have to consider. The weight is acting in the downward direction. This is of m into g. If I consider the mass of the object as 2 only. Okay. Now I will substitute the value later. At first we have to make equal all the forces because the object is in equilibrium position. So all the upward forces will be equals to downward forces. So in upward direction, which forces are acting? As you can see in the upward direction, T sin 30 and T1 cos T1 sin 60. These two forces are acting in the vertically upward direction. In the downward direction, only the weight of the object is acting. The weight of the object, it should be 2 into 10. if I assume the gravitational acceleration as 10 meter per second square. Equation number 1. Now, all the right hand side forces is equals to all the left hand side forces. That means T1 cos 60 is equals to T cos 30. So T1 cos 60 is having a value of half. T into cos 30 is having a value of root 3 by 2. Right? So 2 cancel out. So T1 is equals to T multiplied by of root 3. Right? So we have got a relation now. T1 is equals to T multiplied by root 3. So we can substitute the value here. So it is T sine 30. T sine 30 means T multiplied by 1 by 2. T1 sine 60. Sine 60 means root 3 by 2. It is equals to 20. So now I am substituting the value in equation number 1. So it will be T by 2 plus of. T1 is having the value of how much? T1 is having the value of T multiplied by root 3, right? So it will be T multiplied by root 3 multiplied by root 3 by 2. So it is equals to 20. Up to this much, tell me. Whether everything is clear?
Sir, where did the 2 into 10 come from?
2 into 10, it is equals to m into g. Just wait. Let me erase that thing. This is actually m into g. I have directly substituted the value because all the upward forces is equals to all the downward forces. All the
Yes, sir.
upward forces means T sine 30 plus T1 sine 60. It is equals to the downward force, that is equals to the weight m into g. So m is having the value of 2, g is having the value of 10. So that's why it is 2 into 10, 20. Right? M into g you can calculate here. This is of 2 into 10, it is of 20 Newton.
Yes,
Okay?
sir. Yes, sir.
Now, up to this much, whether it is clear?
Yes, sir.
Now let's proceed. This should be of t by 2. And this is of root 3 into root 3. It is how much? Root 3 multiplied by root 3. It is equals to 3.
3.
So I can say this is of t into 3 by 2. It is equals to 20. So if I take t as common, this will be of 1 by 2 plus of 3 by 2. It is of 20. 1 by 2 plus 3 by 2. It is of 1 plus 3 by 2. It is of 20. 1 plus 3 by 2. It is of 4 by 2. It is of 20. So 2 ones are 2, 2 twos are 20. Sorry, 4 2 twos are 4. So this is 2 tens are 20. So T is equals to 10 Newton. If T is equals to 10 Newton, then T1 is equals to root 3 multiplied by of T. Right? So T1 is equals to 10 root 3 Newton. I'm just giving you the last slide. Watch it fast. Oh,
Sir,
sorry,
next.
okay, I have just taken lots of time now. For your next class is there.
Sir, done.
Okay, that's very good. Up to that much, if it is clear or not, everyone,
Yes,
you
sir,
can
it's
watch the
clear.
video later also to make this concept revise. You can watch this video later. You can understand it again if there is a confusion. Okay. Now, in the exam, actually, I just want to give you the free body diagrams. That's why I'm just completing it at first. So thank you so much. Bye bye.
Thank you,
Take
sir.
care. Bye bye.
Thank you, sir.